Good morning, everybody. Yesterday we had our last session, and then we thought we have to wake up people. Today we are first, but we still don't see many people here. But nevertheless, good morning. And today we are here to introduce another technology, which we believe is another cutting technology, which would solve all our, the menace in water sector. What if I say we have a technology which needs, especially for the disinfection, which needs no additional chemical, and it's small as like I could hold it in our hand. Is that possible? Yes, it is possible. At Enzen, we believe in making possibilities possible, and we are a group of passionate people who always, like yesterday also I told the same thing, we always look for what is next in this world. And also, we are a group of passionate people who are very conscious about energy and water. So given the water stress prevailing in globally, so what we believe is like every drop of water should be used to extend effectively and efficiently. And we have been in this industry for past a decade, and then we believe in delivering values, creating a greener and better tomorrow. WHO, World Health Organization, has put us in a bright spot, saying that we are one among the top 10% of the people who get the clean drinking water in the world. So, like as you could see, the statistics says it's over 94% of people get the clean water. But yet, we keep hearing these pathogen outbreaks and waterborne diseases and water, related to the quality of water. And also, in one of the studies, World Bank also clearly mentioned that close to 21% of the communicable diseases are because of the unsafe water. So what is that like, it could be the message that there is the huge contamination happening. What could be the reasons? There could be only two possible reasons. One, the water resources, the sources what we have as a drinking water sources are either contaminated. Again, statistics goes back where only 30% of the wastewater is getting treated, or the treatment facilities what we have, either they are inadequate or inefficient. Again, we are talking about only disinfection here, keeping other treatment things away. So the robust disinfection is the necessity for the day so that we could avoid all these pathogen outbreaks. So is that we don't have a robust disinfection? No, we do have it. Like over decades, we do been following up. There are several methods available. Each method has got its own limitations, and also they have their merits. But the top two things which we feel which is really critical at this point is, one is the handling of the hazardous chemical, which like in India, again, we are especially the people who have to go through this handling and all that stuff. Another one is the major operation and maintenance cost to go through this, because unless you maintain this this process effectively, preventative maintenance is essential to have the better efficient system over a period of time. So you can see there are a lot of merits and demerits on top of it. So if you come leaving the treatment and then come to the cost part of it, capex is inevitable. And the operation and maintenance is the something which you have to go through. So the lesser is the better is what we believe in. And on top of again, those are the some numbers which we took based on what we are doing right now. It's around 5.5 lakhs for a complete 1 year to maintain a 1 MGD plant. On top of it, there's this cost of transportation, cost of storing, inventory, manpower to maintain that. And also, in India it's not that bad, but if you look at the other countries, there is a huge penalty going to be imposed on the utilities if you don't maintain those qualities. And above all, the cost of risks to the human life is something we cannot afford to do it. And it's also you cannot, you can't just take it. So like we have a good treatment process and we do have people maintaining it, but still why is that we keep hearing these outbreaks? And again, looking at some of the statistics, there's only 25% of the reasons fall onto the design failures, but rest 75% either due to the human error or a negligence, or it may be because of it needs a human dependency. So when looking at all these staggering numbers, statistics, I think it's a time that we need a technology which is chemical free. Second one is with a minimum or comparatively the less operational maintenance hassles, and with minimum human intervention, which could be managed from anywhere and then monitored from anywhere, and something with a high efficiency. So again, talking of Enzen, with our decades of experience, we've been working with utilities, and then we know the pain areas of these things, and then that's where we come into picture, saying that we don't have to crib that we don't have these technologies, but we can definitely come up with these things. And that's how we started looking around for the world's best technologies available. One of the and also at Enzen, we believe in that if we can't do it, we have to do it in some other way so that it benefits the human life. So one such technology is the electrolytic disinfection. And this electrolytic disinfection, we bought it from, it's one of our technology partners from Australia. We believe that it aligns with our vision of making water affordable through innovative and then sustainable solution. So with this, I would like to hand over the stage to our partner, Mr. Rob Richardson, he's the inventor of this technology, and I'm sure he would give you more light on all the technology and other stuff. Over to you, Rob.
Hello, everybody, and thank you for the opportunity through Enzen and the Aqua Foundation to invite us here today. We're very happy to be here to tell you about the launch, if you like, of our technology here. We think it has a lot of application. We've spent about 15 years developing it in Australia, and the applications here, I think, are enormous, with the focus on the life cost. Now, if I can fly this, we'll see what happens. Yeah. Nope, the other one.
Yeah, you could just add us to.
Oh, that's probably easier. Yeah. Basically, the Hydrodis unit is an electrocatalytic process that has a two-stage disinfection. So it disinfects water without the use of any chemicals. We don't add anything. There's no pH correction. There's no chlorine added. It uses the electricity with the salinity in the water. So it has application in potable water, drinking water, which is fundamentally today, but certainly wastewater in the final tertiary stage of disinfection of wastewater, and pre and post filter treatment, which is the removal of contaminants from groundwater prior to treatment for drinking. The science behind it is fundamentally fairly simple, but it was pretty hard doing it. But the science is that it's an electrolytic disinfection is the primary stage, so that kills bacteria, viruses, etc. electrolytically, which is from the components of the breakdown of water. The second stage is a proprietary catalytic coating that produces chlorine from the chloride present in the water. So again, nothing is added, it's already there. Excuse me. A typical layout is a schematic there where water would be either supplied by a pump at the system or it's a pressurised main, but it's a total flow. All the water goes through the cell, filtered first if necessary, through the cell, it's disinfected, and then it's distributed. Now, whether that's into a tank or into a reticulation system, but primarily the water just flows through the cell, it's disinfected, it leaves the cell with a chlorine residual that can be preset, or it can be, as in this case, controlled by a chlorine analyzer with a feedback. The overnight development of 15 years started off in 2002 with what we called our Generation 1 cell, where we were developing the coating to enable us to produce chlorine from low TDS water. And our definition of low TDS was less than 2,000, but realistically we wanted it less than 1,000. So we spent a lot of time developing the coating, formula, etc., to get it into a form where it could do that. And the Generation 1 cell produced that, but the flow dynamics weren't great, so we spent the next few years developing what was our Generation 2, which was a much more efficient method of housing those plates and doing the disinfection. The issues were common for Generation 1 and 2 in that they would scale up. Invariably, there's calcium and other metal and other ions in the water that precipitate out in electro processes, and they would foul the machine. So we spent a lot of work trying to work out how to clean them, how to minimise the scale. Then we sort of had a bit of an idea to think, well, why don't we produce a cell that doesn't scale in the first place? That was our Generation 3 cell, which we now have. And that is a cell that, through flow dynamics and configuration, does not scale. That means it takes out two aspects. The cleaning regime, which invariably is a manual process, and it also, more importantly, takes out the potential for the performance to drop because of scaling. So what it means, it takes out those that I mentioned, but it also takes away all, as Chethana mentioned, takes out all the issues associated with chemicals, transport, storage, handling, the occupational health issues. More critically, the variability in dosing rates. And also, one that's not there is our system does not produce anywhere near the amount of chlorinated byproducts that typically chlorine-dosed systems do. We don't have any high zone or high concentration zone of chlorine, which in a dosing situation, that's where you produce the chlorinated organics particularly. Our system doesn't do that. There are other, and I'll just briefly go over these, but basically the other advantage are it's fully automatic, it's virtually maintenance free. It needs no calibration, it needs no input from operators. A low skill person can just look after it to make sure someone hasn't actually run over it or done something to it. It can be run by solar power, it's very low energy, and it's very effective because it has no waste. No water is lost. This one just briefly compares the advantages and disadvantages with other methods of disinfection, and it shows that the cost advantage of this system, the footprint is much smaller than the others because there's no energy or cost associated with chemical manufacture, container manufacture, transport, disposal of containers, all those sort of things are gone, and it does produce a chlorine residual. Now, this one is the first of a case study that we did. It was the first one we actually put into a site. It was a mining camp where they're doing exploratory work in regional South Australia. There was about 35 people on that camp, and they required about 7,000 litres per day of safe drinking quality water. They also used it for showers as well. So we put a cell in there, our Generation 1 cell, and it ran for 4 years without any failure. And the mining industry is very strict on health issues, and they were monitoring that water over that 4 years, and there was not one exception. The system was only decommissioned when the camp was deactivated and came back to Adelaide. The second one was a potable water system that was put into a regional town in Western Australia. They were at the end of about a 500 kilometre long main that the water had no chlorine residual at the end, and the quality was compromised. And so we put a system in there. It was one that we sent over for trial. They bench tested, spent about 2 years playing around with it in the laboratory, and then installed it, and it ran for about 4 years before they needed to replace the plates. That was in excess of 20,000 hours of operation, during which time there were no exceptions again. And that was a township that had almost weekly exceptions of water quality. The third one, which is the application, I'll go very briefly on that, for the pre-treatment of groundwater. It's used, because it's an oxidative system, it actually can remove iron and manganese in particular, which is the issues in this township, and it enables the removal of those metals much more effectively. They were using chlorine gas before and getting 75% of iron removal, and I should have my glasses on, shouldn't I? About 38% or so of removal of manganese. Once our system was installed, all of the iron was removed and 65% of the manganese was removed. So a tender has just closed for the upgrade of that site in Western Australia. Was put to 5 tendering companies, but our technology is specified for all of them, so they have to use this. So our system has been checked against, and it exceeds the requirements of the Australian Drinking Water Guidelines, which are as stringent certainly as the BIS, so it's an internationally recognised system for water quality. We have certification by the local Department of Health in South Australia that it's a dual-stage disinfection process that produces a measurable, controllable residual of chlorine, which is critical. And we're quite proud of these two. We received 2 awards this year. One was the Innovation Award for Freshwater Thinking by the South Australian Water Corporation, and another one from the Water Industry Alliance for a Smart Water Award. So we're pretty happy about that. There's a testimonial here from the Western Australian Water Corporation regarding that Babacan trial that I spoke of before, where they are very happy with that. It's been in place 9 years now, and they have not had any issues. So we strive to ensure that the efficient treatment of water, we maintain the resource value. Water is valuable, and life is even more valuable, and we are really looking forward to having an impact on the life of people in India. So thank you. Just before I go, I better show you this. I suppose we brought it. This is a demonstration cell that we put together before we came over. This will process about 5,000 litres an hour of water to turn into drinking water. And it uses 24 volts and about 5 amps. So 140, 150 watts of power for 5,000 litres of disinfected water. On that, thank you.